Every time Yellowstone makes headlines, it's usually the same story. A minor earthquake swarm, a slightly hotter geyser, and suddenly half the internet is convinced America's supervolcano is about to blow. But ask an actual volcanologist which volcano genuinely worries them the most, and there's a good chance they won't say Yellowstone at all. They'll point you roughly 59 miles southeast of Seattle to a postcard-perfect glacier-covered peak that most people see as a scenic backdrop rather than a threat. That volcano is Mount Rainier. According to the US Geological Survey's own hazard experts, it poses a more immediate, more populated, and more poorly understood danger than the supervolcano everyone actually talks about. Let's get right into it. Let's start with why Yellowstone, despite its reputation, isn't actually the volcano keeping scientists up at night. Yellowstone is enormous, and its past eruptions were genuinely catastrophic on a continental scale. That part of its reputation is real. But supervolcano eruptions of that magnitude are also extraordinarily rare, occurring on timescales of hundreds of thousands of years. Current monitoring shows no indication that Yellowstone is building toward anything like that in any time frame relevant to anyone alive today. Every earthquake swarm or shift in geyser activity at Yellowstone tends to spawn a fresh wave of apocalyptic speculation online. But scientists who actually study the caldera have been consistent for years that these signals don't indicate an imminent eruption. In the US Geological Survey's most comprehensive National Volcano Threat Assessment, Yellowstone doesn't even top the list. Kilauea in Hawaii ranks as the single most dangerous volcano in the country, followed by Mount St. Helens and then Mount Rainier in third place. 3 of the top 5 most dangerous volcanoes in America, according to the federal government's own risk ranking, are sitting in the Pacific Northwest, not Wyoming. Now, let's talk about why Mount Rainier specifically has volcanologists so concerned. Because the danger here isn't really about the size of a potential eruption at all. It's about what happens to the ice sitting on top of the mountain. Mount Rainier stands 410 feet tall and carries 25 major glaciers, containing more snow and ice than every other volcano in the entire Cascade Range combined. According to the USGS Cascades Volcano Observatory, if even a relatively small portion of that ice were melted by volcanic heat, it would generate enough water to trigger a lahar, a fast-moving flow of volcanic debris, mud, and melted ice capable of traveling for dozens of miles down river valleys at speeds that give residents very little time to react. Carolyn Dreger, a hydrologist and outreach coordinator at the USGS Cascades Volcano Observatory and one of the world's foremost experts on Rainier, has been direct about this. She calls it one of the most hazardous volcanoes in North America, citing not just the potential eruption itself, but the sheer number of people living in valleys that historic lahars have already reached in the past. Here's the number that should genuinely get your attention. At least 80,000 people currently live in zones that future lahars from Mount Rainier are absolutely capable of reaching, based on the mapped paths of previous events. Some broader risk assessments put the number of people threatened by a Rainier-triggered disaster, when you include the wider Seattle-Tacoma metro area and the Columbia River drainage system stretching into southwestern Washington and northwestern Oregon, at closer to 300,000 people. That's more than any other active volcano in the United States poses a risk to directly. This isn't a remote wilderness hazard. Rainier sits within daily view of one of the largest, most densely populated metro areas in the entire country. Why the warning could be so short? Let's talk about why this threat can arrive without the kind of warning most people picture when they think about a volcanic eruption. Bradley Pitcher, a volcanologist at Columbia University, has explained that Mount Rainier carries roughly 8 times the amount of glacial ice that Colombia's Nevado del Ruiz volcano had when it erupted in 1985. That 1985 eruption triggered a lahar burying the town of Armero and killing more than 23,000 people in a single catastrophic night. Pitcher's point is direct. Rainier has the potential for a mudflow event on a scale that could be even more catastrophic than that historic disaster. And critically, a lahar at Rainier doesn't necessarily require a full eruption to happen at all. The mountain's extensive hydrothermal system has, over thousands of years, chemically altered large sections of the rock inside the volcano, weakening it into a substance geologists describe as almost concrete-like when it hardens, but capable of behaving like quicksand when it fails and starts moving. That means a large section of the mountain could theoretically collapse and generate a devastating lahar, even without any actual eruption triggering it. That's a hazard scenario that doesn't require magma reaching the surface at all, just enough heat or seismic disturbance to destabilize already weakened rock high on the mountain. This isn't a hypothetical concern based purely on theory. Rainier has produced exactly this kind of event before, on a massive scale. The Osceola mudflow, which occurred roughly 5,600 years ago, sent a lahar surging more than 30 miles from the mountain's summit, burying huge sections of what are now heavily populated river valleys under layer after layer of volcanic debris. Geologists studying the deposits from that event have found that entire communities in the Puyallup and Nisqually River valleys today sit directly on top of ancient lahar deposits from Rainier's past. That history isn't ancient trivia. It's a direct map of where a future lahar is expected to travel again, because lahars tend to follow the same river valleys repeatedly over geologic time. Let's put Mount Rainier's actual eruptive history into context, because it hasn't been dramatically active in the way people might assume. According to the USGS, the volcano's most recent significant eruption phase ended approximately 1,000 years ago. The last confirmed volcanic activity at Rainier was a series of minor steam explosions back in 1894 and 1895. Genuinely minor events, not a major eruption. Since then, Rainier has sat largely quiet for well over a century. That's exactly why most people who see it every day from Seattle or Tacoma think of it as scenery rather than a live hazard. But quiet doesn't mean inactive. The mountain sits directly within the Cascadia subduction zone, where one tectonic plate is slowly grinding beneath another, and that ongoing collision produces roughly 20 minor earthquakes at Rainier every single year. Rainier remains one of the most heavily monitored volcanoes on the entire planet, specifically because of that combination. A genuinely active magmatic and hydrothermal system, sitting quietly beneath one of the most extensive glacier systems in North America, directly above a major metropolitan area, the warning system. So what is actually being done about this risk? And what would a real lahar warning look like if one started today? The good news is that Rainier isn't being ignored. Pierce County, Washington, working alongside the USGS, operates a dedicated lahar early warning system, with acoustic flow monitors and seismic sensors placed along the river valleys most likely to be hit, primarily the Puyallup and Nisqually corridors. If a lahar begins moving down the mountain, those sensors are designed to detect the ground vibration and acoustic signature of the flow and immediately trigger an alert to communities downstream. That gives residents in towns like Ording, which sits almost entirely within a mapped lahar hazard zone, critical minutes to evacuate before the flow arrives. That system has been undergoing upgrades in recent years, specifically to add more sensors and improve real-time response capability, including additional coverage in the Nisqually River Valley, to match what already exists along the Puyallup. Evacuation drills. Evacuation drills tied to this exact scenario have already been tested in the real world, and the results have been genuinely encouraging. In one recent large-scale drill, roughly 1,450 students and teachers across schools in the hazard zone successfully demonstrated that they could walk out of the mapped lahar danger area within the warning window the system is designed to provide. That's a meaningful data point. It shows the warning system and evacuation planning can actually work if residents know their routes and take the drills seriously. But officials involved in that planning have also been clear that ongoing community education is essential because a warning system only works if the people it's protecting actually know their evacuation route before they ever need to use it, not while a lahar is already moving toward their neighborhood. Let's also address directly why this danger can strike with so little warning compared to what most people picture from volcanic disaster movies. A classic eruption, the kind that builds visible pressure, sends up ash columns, and gives scientists days or weeks of escalating seismic activity to track, isn't actually the scenario volcanologists worry about most at Rainier. The lahar risk is different because it can be triggered by processes happening deep inside the altered, weakened rock of the mountain that aren't always visible from the surface until the moment a slope actually fails. That's precisely why the acoustic and seismic monitoring network matters so much here. It's designed to catch the earliest physical signs of a debris flow already in motion, rather than relying on the kind of longer-term eruption forecasting that works for more traditional volcanic hazards. Now here's the important context that keeps this from being pure fear-mongering. None of this means an eruption or a major lahar at Rainier is imminent. There is currently no indication from ongoing USGS monitoring that Rainier is showing signs of an eruption in the near term. The volcano remains in exactly the kind of quiet, closely watched state it's been in for well over 100 years. What makes Rainier genuinely dangerous isn't an active countdown toward disaster. It's the combination of enormous glacial mass, a large nearby population, a hazard type that doesn't require a full eruption to trigger, and a warning window that could be measured in minutes rather than days if conditions ever did destabilize. That combination is exactly why volcanologists rank it as one of the country's most hazardous volcanoes, even during a period of complete quiet. If you live anywhere in the Puyallup, Nisqually, or wider Puget Sound river valleys downstream of Mount Rainier, here is what officials actually want you to know. First, learn whether your home, workplace, or your children's school sits inside a mapped lahar hazard zone. Pierce County and the USGS publish these maps publicly, and knowing your zone status before an emergency is the single most useful thing you can do. Second, know your evacuation route on foot, not just by car, since roads can become blocked or unusable in a fast-moving debris flow event. The successful school evacuation drills in this region were specifically built around walking routes to higher ground. Third, if you ever hear a lahar warning siren or receive an official evacuation alert for this hazard, move immediately toward higher ground rather than waiting for visual confirmation of a flow. The entire value of the acoustic monitoring system is the head start it buys you before the debris flow is anywhere close enough to see. Fourth, participate in local lahar evacuation drills if your community offers them, since the data from past drills shows that practiced routes save real time during an actual event. And finally, understand that this hazard, unlike a hurricane or wildfire, may come with a warning window measured in minutes rather than days. That makes advanced preparation, not last-minute reaction, the only reliable form of protection available. Here's the honest takeaway from everything we've covered tonight. Mount Rainier is not erupting. There's no current sign that it's building toward one, but it remains, according to the federal government's own hazard rankings, one of the most dangerous volcanoes in the entire United States. That's not because of its size, and not because of any imminent activity, but because of a specific, well-documented combination of massive glacial ice, a huge downstream population, and a hazard that can be triggered by processes happening deep inside the mountain that don't always announce themselves in advance. Yellowstone gets the headlines. Rainier gets far less attention, and according to the scientists who study it most closely, that's exactly backwards. If tonight's breakdown helped you understand a risk that doesn't get nearly enough attention, hit subscribe and turn on notifications so you don't miss it if monitoring conditions at Rainier ever change. Stay safe out there and take care of each other.